Alright, so let's go ahead and continue. So now that I've pulled this 2i out, I can look, and 8, 2, and 6 all have a 2 in common. So I can go ahead and reduce all of my numbers by that 2. Okay, so let's look at this next one. So negative b plus or minus the square root of b squared minus 4ac, and all of that divided by 2a. So let's go ahead and see what I have underneath my radical. So I have 15 squared, which should be 225. And then I have 4 times 12 times a negative 4, which is actually going to change this to an addition. And then 2 times 12 gives me 24. So let's go ahead and continue to simplify. So 225 plus 192 gives me 417. So if I'm going to try to break 417 down, I need to see if it is divisible by any numbers. So, oops, that's still over 24. So let's go over here, 417, let's divide by 3. So 1, with 112, which will give me 3. 139. And I don't think 139. Nope. So I don't think I can actually break that one down any further. That is going to be my answer. So let's come over here. So x equals negative b plus or minus the square root of b squared minus 4ac, and then all of that divided by 2a. So negative 1 plus or minus the square root of 1. And again, I have a negative and a negative. So when I multiply this, it's actually going to become a positive. So I will be adding 4 times 4 times 3. And then all of that divided by 8. I end up with the square root of 49, which we know is a perfect square. Now, when I do this, I'm still going to get 2 solutions. So I get negative 1 plus 7, which gives me 6 divided by 8. Then I have to do negative 1 minus 7, which gives me negative 8 divided by 8. So when I reduce, I get 3/4 and negative 1. Alright, so solve using square roots. When I solve using square roots, I'm trying to get the x squared term completely by itself. So right here, the first thing I'm going to do is I'm going to go ahead and add this 5 to the other side. And I'm going to end up with 27. Still not quite by itself, so I'm going to divide by the 3, and I get x squared equals 9. Well, if I'm doing an inverse operation to undo a squared, I square root. Square root of 9, I'm going to get a positive and a negative 3. Okay? So let's look at this one. So first thing I'm going to do is I'm going to go ahead and add the 100 to the other side. Negative 3x squared equals 243. So then I'm going to do 243 divided by a negative 3. And then I get x squared equals negative 81. I'm going to square root. Now I have a negative, which means I know I have an I involved, but the square root of 81 is 9. And then I have my I for my imaginary. Right here, I'm just going to go ahead and divide by my negative 13. So I get x squared equals 3, negative 3. So when I square root, I know I have an I, and then 3 is already in its prime factorization form, so that's as far as I can go. So over here, I'm going to add my 3. So I'm going to end up with a negative 56. And then I'm going to divide by my 2. So negative 28. So then I'm going to square root both sides. Oh, I'm running out of room here, sorry. So I end up with a negative 28, then I'm going to square root both sides, and again, I know that with the negative I have an imaginary, but I need to see if I can break 28 down. Okay, so I'm looking for pairs. So I'm actually going to be able to pull out a 2, and I already have that I, and my 7 is still left.